All right, we're going to talk about linear equations in one variable and proportions. Okay, you guys have done this before. So a linear equation in one variable is in the form ax plus b equals 0, where a does not equal 0. Okay, so addition property. So if a equals b, and we have some value c, then a plus c equals b plus c. Those are equivalent expressions, right? I'm not actually changing the equality of it. Multiplication, a equals b, and ac equals bc. These are going to be equivalent expressions also, right? I'm not changing the equality of it. So with that in mind, we're going to solve here. And remember, a lot of people are like, well, some of you guys might be thinking, oh, well, what about subtraction? What about division? Okay, yes. Remember, division is just multiplying by a fraction. Let's say if I want to divide by 3, I'd multiply by the fraction of 1/3. So there is some idea here of addition and subtraction built into this one, and multiplication and division here. Remember, you can't divide by 0. So here it says solve. Okay, so the first thing I'm going to do is isolate my variable. So I'm going to move the 3 over. So I'm going to subtract 3 over. 2x equals 14. Divide by 2. Divide by 2. X equals 7. So a lot of you guys are probably pretty familiar with these. That's awesome. So here now I'm going to distribute my 2 through and combine like terms and then simplify. So I'm going to distribute my 2. So that gives me 2x minus 8 minus 5x equals negative 5. I'm going to combine here. So 2x minus 5x is negative 3x minus 8 equals negative 5. Add my 8 over. Negative 3x equals 3. And now I'm going to divide by negative 3. And I get x equals negative 1. Okay. So just a couple more of these simplifying. We have a fraction one here because a lot of students have problems with fractions. They immediately see a fraction and kind of freeze up. So we're going to talk about that. Here I have variables on each side of the equation. Now when I see a variable on both sides, I'm going to simplify each side first. Okay, so if I had to distribute and do that kind of stuff. And then I'm going to take the one with the smaller coefficient and move it to the other side. Okay, so I look here, I have a 5 and an 8. 5 is smaller than 8, so I'm going to move this 5x over. What that does is that allows me to isolate my variable here. So 8x minus 5x is 3x plus 24. And it allows me to then actually work with a positive coefficient there. So now I'm going to subtract off 24. So now I get minus 36 equals 3x, and I'm going to divide by 3, and I get x equals negative 12. There's my answer. Now, when we're dealing with fractions, a lot of times we don't want to work in fractions. Well, if you don't want to work in a fraction, that's fine. Get rid of the fraction. And the way we're going to get rid of this fraction is I see that I have a denominator of 2 and 5. So I need to have a common multiple of both 2 and 5. Well, a common multiple is 10. So remember, if I multiply both sides by 10, I'm not changing the equality of it, right? So multiplication said I can multiply by a number on both sides and I maintain equality. So this goes in here, so I end up with 5 times 3x. Here I distribute my 10, so I have 10 times 8x over 5 minus 4 times 10, and so 5 times 3x is 15x equals, so now I have 2 here, right? So this gives me 16x, because 5 goes into 10 twice. 2 times 8 is 16. So 4 here gives me negative 40. Now, I'm going to go ahead and do the same principle. A lot of times this is a one kind of unique one where I probably just move my 16 over because then I already have my variable isolated. So I'm going to go ahead and do that. Minus 16x, kind of went away from my rule I did up here. Minus x equals negative 40, only because I saw that I would already isolate my x by moving my 16. So they're both negative, so I'm actually going to multiply by a -1, and I get x equals 40. Now, proportions. A proportion is when two fractions or two ratios are equal to each other. And usually what we're going to do is we're going to look at solving those by cross products. So if A over B equals C over D, then AD is going to equal BC for when B does not equal 0 and D does not equal 0, right? Which makes sense because we can't divide by 0. So what we're going to do here is we're going to come here and we're going to multiply here. So x times 7 is 7x. 5 times 63, well 5 times 3 is 15. 5 times 60 is 300, so I end up with 315. Now I need to divide by 7. So I'm going to divide by 7, divide by 7, so I get x equals, what is that, 45? And there's my answer there. Okay. Now the next one I have variables here. So I'm going to go here. I'm going to take my x, multiply it by 20. So I end up with 20x equals, I'm going to take this whole piece and multiply it by 30. So 30 times x minus 10. So I have 20x equals 30 times x is 30x minus 300. Now this is kind of like that last one where I kind of, or a couple problems ago, I saw that I have already x over here. So I'm going to actually just subtract over my 30x. So minus 10x equals negative 300. Divide by negative 10. And I get x equals 30. And there's my piece. So remember, proportions are a way that you can take and multiply across. So you're going to take the denominator of each, use those cross products.